that takes us to the option of being able to plan studies. We've been there before with the mean a little bit, and we'll do a simple version of it here. Knowing how to compute the confidence interval. And we give the width, or more exactly the half width of the confidence interval, we give the name the margin of error. Right? This is exactly taken from the formula for the confidence interval. It's the proportion plus minus the margin of error. That's the name for what gives us the confidence interval. Looking at that one, we can turn it around. And we can, if we have some wish or requirement to the margin of error. That is, given I know how precise I want my study to provide a proportion to me, I can use that definition of my precision, my given margin of error, to turn the confidence interval formula around and say, then I need this size of n to make that work, at least to some extent. Because this is a really annoying formula. This is a formula that should tell us how large is study, how large it should then be, how many people should I put in my poll to get a valid, reasonable, precise result. The purpose of the poll is to identify the underlying proportion P. Well, I just need to know P in order to find out what the n should be to know P. Can you, if my exaggeration here, can you follow? There is a circular thing here. It's a good start, but it's not really workable because we don't know P. That's why we do the study. But we need to know P to be 100% exact on how large the study should be, because it depends on P, how large n needs to be. Well, there is a low practical version of that. Either we speculate or scenario-based, like in the Macron case. Now we already know, probably it's close to 50-50 or at least maybe 60-40 case. It's not a 1%, 99% situation. If we're going to make a poll to investigate proportion of French that votes for either Macron or Le Pen, we know roughly where we are. So we can use that when we do the planning. Or there is another approach actually, which may be expensive, but if we really don't know anything about what the P could be, we could sort of take the worst case scenario. Because the fact is that the function of P, the well-known parabolic function, not the best, but it's there, it maximizes in the middle with a value 1/4. Doesn't take too much of function investigation to identify this to be the case. So we could take the P, 1 minus P, and put in 1/4 instead, and we have sort of an upper limit, right? Let's try. Remember when I did what did I have before? Should we just check what was my precision when I did my survey on the left-handedness? It was plus minus, for the confidence interval, it was plus minus 6 percentage points, right? Plus minus 0.06. Where I had 100 people in the sample to find that precision. Why don't we, a good requirement to a percentage to make it really valid would be, I really want it to be known with plus minus 1 percentage point, right? If you give me a percentage, I want to have it with a precision of plus minus 1 percentage point, so plus minus 0.01. What would that provide? What would that require? I'm sorry, here. Well, let's do 2. Let's assume, I'm struggling with this. Let's assume we know it's the order of 10%-ish, or at least let's assume that's what we're working at. Then I plug in P1 minus P. I plug in the relevant quantile corresponding to this, I plug in the wanted requirement, the wanted precision, and I get this number. So to know the proportion of left-handedness in Denmark with a precision of plus minus 0.01, plus minus 1 percentage point, I need to ask 3,500 people, or find some kind of database that at least has this amount of data to let me know. What if, just to make a point that the second formula I gave is okay, but it's really not an optimal one. What if I was going for this without any assumption of the size of p? If we were just going, I don't know anything about what p could be. I used the same formula, but instead of plugging in this, I had to plug in 1/4, and it's 3 times as expensive to carry out my study. So it's pretty good to know something about where we are, but sometimes you don't. That's just how it is. Sometimes you need to be the first one to find out before you can gain some information. That was planning to have sufficient precision. Game time. Need to think. Ah, that's getting better now. Good. We knew the confidence interval with 1,000, it was 0.03. I'm asking for 3 times as high precision, or to make the width of the confidence interval 3 times smaller, right? The way the sample size depends on the n is through a square, right? So it requires 3 squared. That is the formula I just showed you. If you don't believe me, you can go check the formula and plug them in. So it's pretty expensive to double precision. That needs quadruple of observation. So information is pretty expensive in that sense. On the other hand, it also means that the first observations are the better ones. So at some point, the increase of information by adding another 100 observations becomes smaller and smaller. Yeah. So which is sometimes the point in the people make, well, it's not always that big data really makes a big difference, depending on what you're aiming at. Because maybe you have full information already at 1,000. So it doesn't mean anything to go from 1,000 to 1 terabyte, because you already knew what the proportion was at 1,000. I'm not saying here that big data is not going to change our lives. It will, but we should think about how we allow it to change our lives. Tyra is back. Good to have you.